Okay, so our topic for today is the design of the connections. So first things, try natin i-design yung kanyang, check natin yung kanyang beam bearing plates. Yung base plate is tapos na previous discussion. So this is the beam bearing plate. So here is the principle. Please take note of the dimensions niya na in-specify niya sa notations. So the B is the width of the flange, width of the bearing plate. That T is the thickness of the plate. This LB, kumbaga itong beam na to is nakapatong dito sa bearing plate na to. So meron tayong LB na ito na length niya na LB. Okay, now, pagka ganito yung situation, okay, dapat yung steel natin, okay, yung steel natin is nakapatong siya sa plate para ma-distribute siya dito sa beam natin. Okay, so same through din dito. Dapat meron din tayong bearing plate na nakalagay. So, meron tayong checking dyan as per AIS, American Institute of Steel Construction, and as per NSCP din, dito din siya chine-check din, web yielding. So how can we check for the web yielding? So there's applied force here, and there is a reaction here. Okay, stress equals force over area. Take note pala to guys, yung K na yan is mula dito hanggang dun sa fillet weld, fillet. Then we have a thickness of the web, TW, and total depth of the beam na D. Okay, now, for checking, okay, for sabi niya dito, the area, the support, if the load is assumed to distribute itself, assume at 1 to 2.5, then the area, the support, dito guys, stress equals force over area lamang siya. So, stress will be the Fy natin, yung allowable stress natin sa Fy. Stress equals force natin yung reaction over by the area. Area natin will be LB multiplied by B. Okay? So therefore, for the web building at the support, that is stress na Fy equals R at the support divided by the thickness of the web multiplied by 2.5 K plus the LB. Okay? So dito, LB plus 2.5 kalahati lang. Multiply natin siya sa thickness ng web. Yung web yielding natin is ito. Yan. So at the support, that is the thickness of the web nung nakapatong na beam multiplied by the LB, length ng bearing, plus 2.5 K. So yan yung subject sa web yielding natin. Okay? So, ayan. Mamaya yung web crippling naman. So that is the area subject for web yielding. So please take note of the yung kailangan natin consider. Thickness of the web multiplied by the LB plus the 2.5K. Okay? So, sa steel design naman, yung K, given naman siya. Okay? So, parang dito. Okay? So, yan. Sa support, LB plus 2.5K. Dito naman, stress is also the Fy equals force. Yung force na yun is yung force na nakapatong dito directly divided by the area niya. Yung area, syempre, thickness ng web multiplied by LB plus both sides 2.5K tapos 2.5K din dito, which is nakuha yun galing dito sa 1 to 2.5 na sloping. Okay? So, that is, ito yung para sa load in between the supports. Ito naman is yung load, nominal load para sa support. Support, tapos ito dun sa directly, kung saan directly na naka-apply yung force. Now, for the LRFD design, wherein sa current na board exam is in-specify na siya, kasama na siya sa board exam. So, i-multiply lang kayo ng 1 para dito sa Rn na makukuha natin. And that will now be the allowable load na pwedeng ilagay doon sa part na yun para hindi magkaroon ng web yielding. So, for ASD naman, i-divide nyo lang siya ng 1.5. para makuha yung allowable load para sa ESD. Okay? Now, for the wave crippling naman, ito yung formula natin dyan for the wave crippling. Okay? So, ito ay para sa interior load, tapos ito naman ay para sa support. So, may ano dyan, it depends upon if LB over D is less than or equal to 0.1 and if LB over D is greater than 0.2. So, wave crippling. Ano nga bang wave crippling, sir? Wave crippling is ito siya. Nangyaring wave crippling pag ganito. Okay? Maaaring bumaluktot yung beam natin ng paganyan. Magkikripple yung wave natin. Okay. So, we need to check the wave crippling in two formula. Okay. So, ayan siya. So, actual na spreadsheet is formula siya. Okay. Tapos, ito din siya. So, chinecheck yung wave crippling ng member. Okay. So, sa support, ito siya. Ito yung formula natin. 0.8 thickness ng web squared 1 plus 3 LB. Yung LB natin, length ng bearing, divided by the total depth of the beam, yung nakapatong, times thickness of the web divided by thickness of the flange raised to 1.5 times square root of modulus of elasticity of the steel, okay, times Fy times Tf over by Tw. That is for interior load, wherein ito ay ginagamit pag yung chin-check natin is yung nandito na part. Okay? Now, para dun sa support naman, check din natin dun sa support. So, dalawa yung checking natin. Dito, sa application, tsaka dun sa support. Okay, so, para makuha natin yung, okay, yan. So, we have a fee of 0.75 and factor of safety of 2 naman para sa ESD. So, please take note of the formula and the capacity reduction factor. Okay? So, yan ay nabanggit din sa steel design natin. So, like this one, may applied load tayo dito. Tapos, syempre, kailangan i-check yung sa support natin dito. Okay? So, ayun, yun yung checking na calculation. So, ito naman sa formula sa pag-compute ng thickness. So, dito. So, design a bearing plate to distribute the reactions. So, meron tayong dead load 4.5 tsaka live load na 4.5 din. So, multiply natin siya sa length, yung uniform load na yun, yung 12.6, multiply natin sa length na 15.3 feet. Then divide natin ng 2 para makuha yung reaction sa support. Okay, so therefore, the force at the support will be 99.73 equals to FYTW times. Since support siya, ang consideration natin is 2.5K plus the LB. Okay, so ayan siya na. So 1 1 times 50. Fy natin is 50 KSI. Okay, so 50 times the thickness of the web thickness ng web natin. That is 50 times 0.43 times 2.5K plus the LB. So, that is allowable load natin is VRN, then LB yung makukompute. We have applied force of 99.73. Okay, so dito, okay, sa steel na W21 by 68, given naman na yung mga properties. Okay, so ayan. So, ang kinocompute dito, sabi niya, design a bearing plate. So, pinapadetermine niya yung bearing plate with spanning of 15 feet and 10 inches in towards the center of supports. So, may dead load, tsaka live load na 9 kips per foot. And the beam is to be supported on reinforced concrete wall with FC prime 3,500 PSI and FY is 50,000 PSI and FY is 36 for the plate. So, ito yung yielding stress para sa beam. Ito naman yung yielding stress natin para sa plate. So, therefore, ayan, i-design natin siya. Ni-resist niya yung 99.73 kips. Therefore, the LB natin should be greater than or equal to 1.66 inches. Okay, so note, two values of K are given dimension properties tables, a decimal table called the design dimensions. So we always use the design dimension calculation. Now, for EIS equation J10-5, determine the value of LB required to prevent web crippling. Okay, so yung ito na LB is based sa checking natin sa web yielding formula. Now, for the checking of the web crippling, ito naman yung magiging equation natin. I-equate natin yung equation doon sa applied force which is 99.73. And since nasa support siya, ito yung gagamitin na formula. So phi 0.4 thickness of the web squared 1 plus 4 length of the bearing divided by the depth minus 0.2 thickness of the web over TF raised to 1.5 square root of EF by TF over TW greater than or equal to RU. Okay. So, ultimate loads, ultimate din yung gagamitin natin dito. So, therefore, merong i-multiply na reduction factor na 0.75. And take note that this formula also is applied to English units. No, English units tayo dito. Ngayon, kung sa board exam is magbigay ng metric units, mag-convert na lang kayo. Okay? At least now, memorize nyo na yung formula. Nadating ang board exam, mako-convert na lang kayo. Okay? So, next one is 0.75, 0.4 times thickness of the web na 0.43. Okay? Then, 0.43 inches, 1 plus 4 LB over D, 21.1. Then, minus 0.2 thickness of the web over thickness of the flange raised to 1.5 times EFY TF over TW na 0.43. So, LB niya dito computed is should be greater than or equal to 3 inches. Now, I need to check the LB over D. So, that is less than 0.2. Therefore, ang gagamitin natin na formula para sa less than 0.2 is yung isa na formula. It should be 1 plus 3 LB over D, TW over TF is 1.5. Square root of EF by TF over TW should be greater than RU. Okay, so dito ang lalabas niya should be greater than or equal to 2.59 inches. So, 0.12 is less than 0.2. Ngayon, dito sa LB na to, dapat greater than or equal to 2.59. That is due to web crippling. So, web yielding naman, it should be greater than or equal to 1.66. So, therefore, kung sino ang mas malaki sa kanilang dalawa, yun yung pipiliin natin. Therefore, LB natin should be 2.59 inches. Okay? Yun. So, that's for the checking ng web crippling tsaka web yielding. Ito naman ay para sa bearing. Okay? Try LB equals 6 inches. So, to determine the dimensions will be from a consideration of bearing strength. If we conservatively assume that the full area of the support is used, the required plate area can be found as follows. Okay? Phi times P allowable equals RU. So, ito yung allowable natin. Okay, doon sa base sa bearing area. Okay? So, dito sa bearing, ito ay kung yung area ng plate natin, ito, yan, kung yung area ng plate natin na nakapatong is presya ng area dito sa concrete. Yun yung formula na gamitin natin sa pag-check ng bearing. 0.85 FC prime area 1 of the steel plate. Now, if yung area ng bearing natin, steel plate, is less than the area ng concrete, ito yung gagamitin naman natin na formula sa pag-check ng bearing. Wherein A2 is the area of the concrete support. Yung area 1 is the area of the steel bearing. But it should be less than or equal to 1.7 FC times the area 1. So those are the allowable loads. Okay, for the plate thickness naman na calculation, we have N times B minus 2K over 2. So ayan siya, B times LB. So ayan yung distribution ng force natin dyan. Then, ayan, we have a formula dyan. Magkakaroon tayo dyan ng formula para sa thickness na ito. Thickness should be greater than or equal to 2 RU N squared over 0.9 BLB FY. Okay, ano yung N, sir? Yung N is, makukuha natin siya dito. Yung N is the distance mula dito papunta doon sa fillet ng nakapatong na beam. Okay. So that is equal to width minus twice ng K divided by 2. That will be the N. Okay. So, this is the thickness. Formula ng thickness natin dyan. Ito. That is for the LRFD. Okay. Ito yung formula, guys. Tapos, yung for the ASD naman, thickness is equals to 3.34 RE N squared over BLB FY. So, dito, compute natin siya. So, try LB equals 6 inches. So, since we have already the minimum, which is 2.59, so, it's up to you as a structural designer if ilan ang gagawin mo. Kung isasabad mo siya sa 2.59 or lalakihan mo. So, dito, gamitin natin 6 inches. Now, determine the dimension B from a consideration of bearing strength if we conservatively assume that the full area of the support is used. Required plate area A1 can be followed as follows. So, na-assume niya na 6 inches na. Okay? Full area. Nakalapat ng buo yung steel plate natin doon sa konkreto na support natin. Okay? So, therefore, yan. Therefore, gamitin natin itong formula to. FC prime 0.65 F times 0.85 FC prime A1. Therefore, yung A1 natin is 51.57. I-divide lang natin sa 6 inches. Therefore, we could have already a value of B which is 8.6 inches. Now, the flange width of W section making plate slightly wider than the flange. So, compute the required plate thickness. Para makuha natin yung plate thickness, gagamitin natin yung formula na T equals product of 2.22 RUN squared over by BLBFY. This 2.22 RU times N natin na 3.81, which is B minus 2K over by 2. So, that is, thickness is 1.22 inches. Okay, so gagawin dyan, split na 1.25 inches, which is 1 and 1/4 thickness by 6 inches by 10 inches na steel plate. Okay, so yun yung gagamitin natin. That is for the LRFD. Okay, so ito naman yung solution para sa ASD. Okay, so sa ASD yung gagamitin niya na plate using doon sa mga formula natin kanina. That is 1.5 by 6 by 10. Sa ASD, mas makapal. Doon sa LRFD is mas manipis. Okay. So this is the design of the beam bearing plates. It should be checked on the web yielding and web crippling. Okay. For the design of the connection naman, is pasok ulit kayo tapos i-design naman natin yung connection niya.